Hi, I'm Kian, and in this video, I'm going to show you how to solve this integral. So this integral I've come up with a lot, and I've seen it a lot, and I'm going to show you my approach to solving this. So you have the integral of 1 over square root of x squared minus 1. Notice that we can't do any partial fraction here. I've seen many students who take calculus who've seen like integrals such as 1 over x squared minus 1 mistakenly use partial fraction for square root denominators, but that is wrong. Whenever we have something to the higher power, especially squared, and in the square root, maybe it's a good idea to do a trig substitution. That's what I'm going to start with. So I'm going to let x to be equal to, so we have to look. So technically sine and cosine won't work because we don't have any identity with like sine squared minus 1 being equal to something. We have 1 minus sine squared being equal to something, but we don't have sine squared minus 1 or cosine squared. We also don't have tangent squared minus 1. We have the integral of, for example, let's say 1 plus x squared. If that is, then the integral of that is inverse tangent. But we can't plug in tangent because it won't give us any identity. But if we plug in secant, it will. Because we know that tangent squared plus 1 is equal to secant squared. So as a result, secant squared minus 1 is equal to tangent squared. So if I plug in or substitute x equals secant theta, and by differentiating, you know that dx is equal to derivative of secant is secant theta times tangent theta. And now we can write this integral as the integral from 1 over square root of this becomes secant squared minus 1, which is tangent squared theta, and then times the dx, which is secant theta times tangent theta. And now we can see that, I'm going to use purple. So now we can see that the tangent theta and tangent theta cancel, and what we have is the integral of secant theta. So this is a pretty famous integral, and we can just write the answer and move on, but I'm going to show you how we can actually solve it. So if you multiply the numerator and denominator, if you write that secant theta over 1 by secant theta plus tangent theta. So what we get is the integral of secant squared theta, down, and then plus secant theta tangent theta, and then over secant theta plus tangent theta. So if I use a u substitution, I'm going to use red here. If you let u to be equal to denominator, secant theta plus tangent theta, or wait, sorry, let me write it again. Secant theta plus tangent theta, you can see that du becomes precisely secant squared theta plus secant theta times tangent theta. Why? Because you know that the derivative of secant theta is secant times tangent, and tangent theta is secant squared, so it matches. So that du is precisely equal to this part. So this is basically the integral of 1 over u, which is just natural log of absolute value of secant theta plus tangent theta. But we said that x is equal to secant theta because we have to go back to x. So we have ln of x, and then plus, since we know that secant theta is equal to x, we can actually draw a quick right triangle where this is theta, secant theta is x, so the hypotenuse is x. Sorry, this is 1, and this is the square root of x squared minus 1. So the tangent theta is opposite over adjacent is plus square root of x squared minus 1. And under absolute value, and then plus c. And that's it for this video. Thank you for watching. I hope you enjoyed it. Please subscribe to my channel, and goodbye.